Welcome to CSMC 2017 Part A, Question 5. The rectangular spiral shown in the diagram is constructed as follows. Starting at the origin, line segments of length 1, 1, 2, 2, 3, 3, 4, 4, etc. are drawn in a clockwise manner as shown. So as shown right here. The integers from 1 to 1000 are placed in increasing order wherever the spiral passes through a point with integer coordinates. So that is 1 at the origin, and then 2, and 3, and 4, 5, 6, etc. in a clockwise manner, like they've shown here. So what is the sum of the first of the positive integers from 1 to 1000, which are written at points on the line y equals to negative x, as they've shown in the diagram here. So let's solve this question. Okay, so let's write out the numbers that we're supposed to sum that are shown in the picture. So we have 1, we have 3, we have 7, we have 13, and we have 21. Now, if we look at this, let's compare the numbers to 1. How far away are these numbers from 1? So the first number, I'll use a different color for this. So the first number is 0 away from 1. The second number is 2 away from 1. The third number is 6 away from 1. The fourth number is 12 away from 1. And so on. If we then see that this one will be, let's just write this down as well. This one will be 20 away from 1. So now all of these numbers, you can see, are multiples of 2. So the pattern clearly is that it's 2 times 0. 2 times 0. 2 times 1. 2 times 3. 2 times 2 times 6, followed by finally 2 times 10, right? So these are the numbers that we're using here. So these numbers, you will notice, if you look at these numbers closely, these are the sum of numbers, sum of integers, natural numbers, or not integers, whole numbers, sorry. So if you look at 0, it's the sum of the first 0 whole numbers. 1 is the sum of the first 1 whole numbers. This is the sum of the first 2 whole numbers, 1 plus 2. 6 is the sum of the first the 3 whole numbers. So 1 plus 2 plus 3 gives you 6. And finally 10 is the sum of the first 4 whole numbers. So 1 plus 2 plus 3 plus 4 gives you 10. So these are obviously then the sum of whole numbers. So the sum of the first n natural numbers is represented by n times n plus 1 over 2. And of course the nth term will be equal to this multiplied by 2 plus 1. That's how far away it is from 1. So multiplied by 2 plus 1. This gives you n times n plus 1 plus 1. Let's go ahead and zoom out from here. So this is the formula. This is the nth term, basically. If you look for, let's say, the third term, it will be 3 times 4, 12 plus 1, 13. So 1 here is considered to be the 0th term. So it would be 0 times 1. 0 plus 1 is 1. So 1 is the 0th term. So now if we want to find the nth term here, it would be, so the nth term is going to be equal to this. That's the nth term. Now we know what the nth term of the sequence is, or where it's 0 indexed, obviously. So we want to figure out obviously is the first 1,000 number, like this is in the problem statement. It's the sum of the first 1,000 positive integers. So we can figure out what like roughly or exactly, sorry, which term is what's the largest term of this form that's less than 1,000, less than or equal to 1,000. And if we try this, we should get, 31 multiplied by 32, I believe, should be the answer. Yep. Plus 1. So n times n plus 1 plus 1 should give you 993. And this is the largest term of this form that is less than or equal to 1,000. So this is the term we're going to use. That tells us that, let's use the color again. That tells us that we're looking at the first 31 terms in this sequence. And so essentially, what this looks like is, let's see. How are we going to write this down? So, if we get this, we know that it's, n times n plus 1. If we try to expand this, n times n plus 1 plus 1, this is equal to, n squared plus n plus 1. So this is the type of expression we have here. And that represents what all of these will be equal to. So, let's see. Once you've got this form, and we know we want the first 31 terms, we can represent this as a summation. So from n equal to 0 up to 31, we want the sum of n squared plus n plus 1. That's what we want to find here, essentially. So this is basically equal to the sum of the first 31 numbers from 0 to 31 squared plus n, the sum of the first 31 natural numbers, which is obviously given by n times n plus 1 over 2, and plus 1 plus 31. This is going to be 31. Yeah, 32, sorry, this will be 32. So now, if we scroll up here, they've given us some useful facts. These will be helpful for this. So they've already told us that the sum of the first n integers is this, and the sum of the first n perfect squares is equal to this. So we want, the first 31 perfect squares. 31 perfect squares we want, right? So that will be equal to, let's zoom out one more time. That will be equal to first 31 perfect squares. Well, according to their formula, which you can derive, is equal to 1 over 6 times 31 times 32 times 2n plus 1. So that would be 63, I believe. Because of 31 times 2, 62 plus 1, 63. And this, I'll do my calculator quickly, gives us 10,416. So that's this component. There's also the n component here. And for that, that's just going to be the sum of the first 31 numbers like this. So starting at 0 and then going up to 31. So it's really the sum of the first 31 numbers. So it'll be 31, let's write this down. First 31 numbers sum. And let's just make a thing here. So this will be 31 times 32 plus 1. Oh, sorry, not plus 1. Over 2. Right? Because that's the sum of n times n plus 1 over 2. And this is equal to, let's use my calculator quickly, times 32 divided by 2, 496. This is the sum of the first 31 numbers, right? And then for each of these iterations, we want to add 1, so that'll be 32. It will be added to this. So the extra, so essentially, the answer will be 10,416 plus 496 plus 32. And this gives me plus 496 plus 32. This gives me 10,944 as your final answer. So that's our solution to some of the first positive integers from 1 to 1,000 that are written on this line.